Hello everybody, welcome to A to Z Learning Hub. Today we start some miscellaneous problems of a CBSE book as well as some extra problems. First we see using set property set properties prove that A intersection B minus C is equal to A intersection B union A intersection C. You see this problem you cannot find this problem in a CBSE miscellaneous exercise, but it is very important. LHS A intersection B minus C is equal to A intersection B intersection C dash, because you know B minus C is equal to B intersection C dash. This is one of the set properties. That is, you can write phi union A intersection B intersection C dash, because any set is in union with phi, give that set. That is equal to, you can write A intersection B in place of phi, we can write A intersection B intersection A dash union A intersection B intersection C dash. You see A intersection B intersection A dash, this is your universal set U, this is your A, this is your B, this is your A, this is your B, this is your A intersection B. A intersection B intersection A dash. Intersection A dash means this. That means you will get phi, because they have no common elements. So we can write A intersection B intersection A dash union, you apply associative property A intersection B intersection C dash. That is equal to, you can write A intersection B distributive law, reverse distributive law, A intersection B intersection A dash union C dash. That is equal to A intersection B intersection A union B dash by De Morgan's law. That is equal to, you can write, this is your A intersection B dash, that is equal to write A intersection B minus, this is your A intersection B intersection A dash union C dash, that is your A intersection C dash, that is equal to A intersection B minus A intersection C. Intersection A intersection C dash means you can write A intersection C. Your proof is over. Again I am telling you A intersection B minus C, that is equal to A intersection B intersection C dash due to this property. That is, you can write phi union A intersection B intersection C dash. That is your, in place of phi I will write from that diagram A intersection B union A dash union A intersection B intersection C dash, that is equal to A intersection B intersection A dash union, you are apply associative property, I can write A intersection B intersection C dash, that is your reverse distributive law, A intersection B intersection A dash union C dash, that is equal to A intersection B intersection, this is your De Morgan's law, A intersection B A intersection C dash, that is equal to A intersection B minus A intersection C. This proof is over. Your another important property, Number 2, if PA, power set of A, is equal to power set of B, then A is equal to B. We have to show. You see, suppose this is your set A, suppose, and you take an element in set, element X in set A, which present in the subset of A, that is X. Similarly, you take the set B, you take an element of B which present in the subset Y of B, that small y. Let proof you see. Small x is an arbitrary element of A. Then there exists a subset capital X of A such that small x belongs to capital X. You see, let X is an arbitrary element of A, small x is an arbitrary element of A, then there exists a subset X of A such that that arbitrary element small x belongs to capital X. So this implies that, so that capital X is the subset of A. This implies that if capital X is the subset of A, then capital X belongs to power set of A, because power set contains all subsets of A. That is, this implies that capital X belongs to power set of B, because PA is equal to PB. This implies that if X belongs to PB, you can write X is the subset of B. This implies that small x belongs to B. X belongs to B means small x, because small x present in capital X. So X belongs to A implies that, so X belongs to A implies that X belongs to B. This implies that A is the subset of B. This is the first part. Again, in similar manner, part 2. Let Y is an arbitrary element of B such that Y is the subset of capital Y of B. So we can write, so this implies that capital Y is the subset of B. This implies that capital Y belongs to power set of B. This implies that a capital Y belongs to power set of A, because PA is equal to PB. This implies that a capital Y is the subset of A. This implies that Y belongs to A. Hence it is clear. So Y belongs to B implies that Y belongs to A. So B is the subset of A. This is another expression. So A is the subset of B, B is the subset of A. From 1 and 2, we have A is equal to B. This is your proof. Second proof, if PA is equal to PB, then A is equal to B. Next, come to your third problem. These problems are very, very important problem. You remember it. Question number 3. Is it true for any sets A and B, that is PA union PB is equal to P of A union B? Justify. You see, In this case, we prove it by taking an example. Consider the examples. Let A is equal to 1 and B is equal to 2. So, PA is equal to what? Your 1 and 5. And PB is equal to your 2 and 5. These are the power set of B. A union B is equal to 1, 2. So, P of A union B, it has all subsets, that is your 1, 2, 1, 2 and 5. Again, PA union PB is equal to what? Your 1, 5 and 2, 5. That is your 1, 2 and 5. You see, P of A union B is equal to 1, 2, 1, 2, 5. P of A union P of B is equal to 1, 2, 5. So, P of A union P of B is not equal to P of A union B. This is your answer. Next, come to another problem, that is your question number 4. Question number 4, for any sets A and B, first we prove using set property. A is equal to A intersection B union A minus B. I will start this proof from RHS. That is your A intersection B minus union A minus B, that is equal to A intersection B union A intersection B dash. Use reverse distributive law. A, you can write A intersection B union B dash, that is equal to your A intersection B union B dash, that is your A intersection U universal set, that is equal to A intersection. Next, your second part is, second proof is A union B minus A is equal to A union B. From LHS, you see A union B minus A, that is equal to, you can write A union B intersection A dash, you apply distributive law. A union B intersection A union A dash, that is equal to your A union B intersection U, that is equal to A union B. This proof is over. This is your question number 4. Next, come to your question number 5. You say, very important problem. You try to understand. Question number 5. Let A and B be sets if A intersection X is equal to B intersection X is equal to phi, and A union X is equal to B union X for some set X, then A is equal to B. Proof you see. We have to show A is equal to B. For this, in part 1 we show A is the subset of B, and in part 2 we show B is the subset of A. First you see, part 1. First we show A is a subset of B. How? It is given A union X is equal to B union X. You take intersection A on both sides A intersection A union X is equal to A intersection B union X. A intersection A union X. A intersection, suppose this is your A, this is your X. So A intersection A union X, that means we can say A is equal to A intersection, apply distributive law, A intersection B union A intersection X. That is equal to, we can write A is equal to A intersection B union A intersection X from hypothesis, that is your phi. So A is equal to A intersection B. Since A is equal to A intersection B, suppose this is your B, this is your A is equal to A intersection B. A intersection B is equal to A. This implies that A is the subset of B. This is the first part. Next come to your second part. From hypothesis, part 2, A union X is equal to B union X, or this, or B union X is equal to A union X, taking intersection B on both sides, B intersection B union X, B intersection A union X, B intersection B union X is equal to your B like A. We can say, apply distributive law, B intersection A union B intersection X, that is equal to B is equal to B intersection A union B intersection X from hypothesis, that is your phi. So B is equal to, we can write B intersection A. So B is equal to B intersection A. B, this is your A, this is your B, B intersection A is equal to B in this set. We can say, so B is the subset of A. This is the part 2. From part 1 we get A is the subset of B, and from part 2 we get B is the subset of A. From 1 and 2 we get A is equal to B. This is your proof. This is your question number 5. Next come to your question number 6. If A is a subset of B, then C minus B is the subset of C minus A. From LHS, you see, let X belongs to C minus B. This implies that X belongs to C and X does not belong to B. This implies that X belongs to C and X does not belong to B. Since A is the subset of B, since X does not belong to B, we can write X does not belong to A. This implies that X belongs to what? C minus A. So X belongs to C minus B implies that X belongs to C minus A. So we can say C minus B is the subset of C minus A. This proof is over. This is very small proof. So this is very small video also. You understand my teaching. Please subscribe my video so that I will be motivated to give you better and better video. For today, thank you everybody.